Hello friends, we have already seen and discussed about the mixtures, their different kinds, their different types and their properties. We have discussed about the solutions, we have discussed about the suspensions, also about the colloidal solution. Even on the basis of different type of dispersed phase and dispersion media in the colloidal solutions, there are different type of colloidal solutions as well. Aerosols, foam, solid sol, emulsion, like that. We have already discussed about all this. Now, let's think. Now we have known that what is the pure substance and what is the mixture. When we talk, is matter around us pure? From pure, we mean pure at the molecular level, pure at the atomic level, pure via its chemical properties. Now, let's have an example of few of the mixtures and how will we separate the constituents, the substances which have made that mixture. How will we separate those substances, those constituents from that mixture? Let's have a look at the first example. Let's have an example of black or blue color ink. Now, what do you think? Is it a pure substance? Actually not, because it has got the mixture of colored dye and water. It's a solution. Now, if we take this solution, how will we separate a colored dye from the water content? There is another example of a solution, a salt dissolved in water. If we want to separate that salt from the water, we use a phenomenon of evaporation. But when we consider a ink, dye may not be like salt, dye may be a volatile substance. So if we start evaporating it, if we start boiling the ink, we may not get the dye. So what is the process? How are we going to separate that dye, that colored particles from the water content of the ink? There is a small example. There is a small experiment. Let's set up that experiment. Let's have a beaker full of the water. Put a watch glass on that beaker. Close that beaker. Now, put this on the flame and put few drops of the ink on watch glass. Now, watch glass is not directly heated. We are not giving flames to ink directly. But water will start boiling, and with the heat of the water vapors, that ink will start getting evaporated. Water content of that ink will start evaporating, leaving back the colored particles, the colored dye, the colored constituent of the ink. This is another way of using evaporation phenomenon for separating the constituents from the solution when there are volatile constituents in a solution. Where do we use this kind of separation process? Specifically in colored dyes. In any solution which has got the volatile constituent, we utilize this kind of separation process for separating its colored constituents. When a volatile solute has been dissolved in non-volatile solvent, each and every solution like that can be separated into its constituent, can be a solute, a volatile solute from such solution can be separated out from this experiment. Let's have a next example. How are we going to separate the cream from the milk? Now we all know milk is a colloidal solution where there are the solid particles of the cream dispersed in the water content, dispersed in the milk throughout. Now, how are we supposed to separate this cream from the milk? there is a process called as a centrifugation. We put the colloidal solution in a test tube. We put that test tube in the centrifuge machine. It is rotated at the high speed so that a centrifugal force acts on that colloidal solution. Generally, it is seen that in any colloidal solution, there are the heavier particles and the lighter particles of dispersion medium. With the centrifugal force, automatically these heavier particles are pushed apart and they get separated at the bottom of the test tube, and the lighter particles stay on the upper part of the test tube. If suppose you people don't have a centrifuge machine in your science labs, school labs, or maybe at the home, you can use a basic churner machine or even a churner stick at home to churn the milk to create this centrifugal force, and just see what you get. You will get the heavier particles of the cream separating out from the milk. This is how, with the help of centrifuge or maybe a churner, we can separate the heavier particles, we can separate the cream from milk. Now, this process of separation, where do we have its applications? Where do we use this kind of process of the separation of the constituents from these colloidal solutions? We use such centrifuge process in the laboratories, specifically for medical testings of the urine, of the blood. When we want to separate some specific cells from the blood, maybe a platelets which actually help us for clotting of the blood, or maybe RBCs, red blood cells, white blood cells. All these different particles of the blood, all these different cells have different masses. Some of the cells are heavier, some of the cells are lighter. So, with the help of centrifuge, we can separate such cells, such components from the blood, and this phenomenon is utilized in the laboratories, and it helps a treatment of the patient in far better way. Where do we use this centrifuge process elsewhere? Have you ever seen the dryer of the washing machine? What does it do? It rotates the wet clothes in very high speed, so automatically the centrifugal force acts upon the clothes and the water particles which are actually drenched into those clothes. So automatically these water droplets are thrown apart from the clothes and clothes gets dried. In the dairy also, this centrifuge is used, because we have already seen the example. Cream is separated from the milk with the help of centrifuge. Let's see the next example. How are we going to separate two immiscible liquids mixture? What do we mean by two immiscible liquids? The liquids which do not get mixed up in each other. They actually separate from each other as a different layer because their density is different. Any oil and water do not get mixed into each other. They do not make a homogeneous mixture. They actually get separated when put together in a single flask. They separate as in different layers. Let's have an example of kerosene oil and a water. If we put in a same flask some water and some kerosene oil, what will you get? Put that flask or put that beaker for some time undisturbed. Automatically, kerosene oil being lighter in the density, it starts floating on the top of the water. It makes altogether a different layer on the top of the water. Water makes another layer at the bottom. Now, such two immiscible liquids can be separated with the help of separation flask, separation funnel. There is this instrument called as a separation funnel, which has got a very narrow end through which we can take out the liquid drop by drop and it has got the stopcock, so that we can stop that flow wherever we want. If we have a mixture of kerosene oil and water, put that mixture into separation funnel and leave it for some time undisturbed. Automatically, being immiscible liquids, kerosene oil and water will make different layers. Bottom layer is a water, top layer is of kerosene oil. Now start that stopcock so that water start flowing from the nozzle of that funnel. Drop by drop, take out all the water, and as soon as the water layer is drained out totally, and kerosene starts, stop this stopcock so that we can get a kerosene oil in a separation funnel and we get the water in any other flask, any other container. This is how we are going to separate two immiscible liquids. Where do we use such kind of separation process? We use such separation process in any mixture of oil and the water. Any kind of oil is actually lighter in the density from the water. So any kind of oil when mixed with the water, if we leave it undisturbed for a while, it makes two layers. Oil forms the top layer and water forms the bottom layer. Also, the pure iron is separated from its ore. When in an iron furnace that iron ore is melted, there is a slag prepared which is actually a lighter than molten iron layer. So these two layers, these two liquids become two immiscible liquids, and automatically we get two layers. One is the lighter slag and the bottom layer is of molten iron. So with the use of this process, this separation funnel, we get molten iron separated from the lighter slag. These are the application of these processes. Let's see the next example and next process of separating the constituents, separating the substances from the mixture. Let's have an example of next mixture, that is a mixture of salt and ammonium chloride. How do we separate its constituents? Now we all know ammonium chloride is a sublimable substance, just like a camphor. Now, when there is such a mixture of two things in which one of them is a sublimable substance, another is non-sublimable. So, for separation of such constituents, we utilize the process of sublimation. What do we mean by sublimation? What is the sublimation phenomenon? We all know that there are some solids which are actually sublime, which are sublimable. So, when the heat is provided, those solids get converted to direct gaseous state, bypassing the liquid state. They do not melt, they directly evaporate from the solid state. We have already seen the example of camphor in our home, in our day-to-day use. So, when there is a mixture of salt and ammonium chloride, put that mixture into a conical flask. Close the top of the conical flask with a cork, and now put that conical flask on a flame. What happens? Ammonium chloride starts sublimation. After the process of sublimation, automatically the gaseous state ammonium chloride is separated from the mixture, from the impurity of the salt, and those gases are actually settled on the glass of the conical flask and they condensed over there, and we get a solid layer of pure ammonium chloride which is separated from the salt. So with the help of sublimation, this phenomenon, we can separate the constituents of the mixture, which is made up of a sublimable substance and non-sublimable impurity. Next example, next mixture we are going to see about is a colored particles in any ink. What do you think? If we take an example of black color ink, we have already seen with the help of evaporation, but not directly on the flame, but on a watch glass put up on the water filled beaker which is on the flame. With help of such evaporation, we can save and separate the volatile dye from the ink. If we take the example of black ink, what do you think? That dye consists of only black color, or is it made up of different color particles put together to give the output of black color dye? Actually, there are different color particles which constitute for making a dye, which after dissolving in the water gives the black color ink. Now, how to separate such color particles from the dye of that ink? There is an experiment. Let's have a filter paper strip. On that filter paper strip, on the bottom, the near to the bottom, let's draw a horizontal line. Now, on the horizontal line, at the center of that line, put a dot of the ink. Let's wait for some time so that that ink gets dried up on the filter paper. Now, put that filter paper in the test tube or a beaker vertically, tied up with the lid on the top. In the flask, in the beaker where we are going to dip that filter paper, have the water, but with such quantity that layer of the water, the surface of the water is slightly below than the horizontal line and dot of the ink on that filter paper. And now that filter paper bottom end is immersed in the water. Now just wait and watch what happens. Once the filter paper is wet, from one end, the bottom end, water starts traveling upwards on the filter paper. And while it travels upward, once it crosses that horizontal line, once that water crosses that ink dot, what do you observe? What we get? Actually, above the dot of the ink, as water level rises on the filter paper, we get different color particles.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. Make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger. The night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
So, with this experiment, how do these different colored pigments from the dye of that ink got separated? Actually, this phenomenon is called as a chromatography. Because whatever that dye is made up of, whatever different colored particles, they have different solubility in the water. As water rises on the filter paper and it crosses that ink, whatever colored pigments which have higher solubility in water, they get dissolved in the water faster and they rise up above in the very first. Now, the pigments which have less solubility, they take some time to dissolve in the water. So, after those pigments which are highly soluble, after those pigments, we get those pigments which have less solubility. This is how, even from the dye of the ink, different colored pigments can be separated. This phenomenon is called as a chromatography, and we use this chromatography to separate the color pigments even from the natural colors. We use this chromatography phenomenon for separating the drugs from the blood. Applications are unending. We use this chromatography phenomenon for separating the colors from the dye also. Let's have an example of next mixture. How do we separate two miscible liquids? We have already seen how we separate two immiscible liquids. Two immiscible liquids means the liquids which cannot make a homogeneous mixture, which cannot get mixed into each other. They make two different layers. But now we are talking about two miscible liquids, means two liquids which actually can get mixed up with each other so fine that they make a homogeneous mixture. Let's have an example of acetone and water. How do we separate this acetone from water? Acetone and water, two miscible liquids, form a very well homogeneous mixture. They do not make two different layers. So, for separating two miscible liquids, we use the process of distillation. Now, we all know what the process of distillation is. We have a distillation flask. We put the mixture into distillation flask, put it on the flame. So, out of two liquids, one of the liquid has got its boiling point way earlier than another liquid. So, from these two liquids, let's have an example of acetone and the water. Water has got its boiling point at 100 degrees Celsius. Acetone, on the other hand, starts boiling at very low temperature. It doesn't need the 100 degrees Celsius to get evaporated, to vaporize. So what happens is, still water is in its liquid state, acetone starts vaporizing and those vapors rise above the liquid. Those get automatically separated. Now, those vapors are already settled on the top floor glass and get condensed and again forms the drop of acetone, and those acetone droplets are collected through the slanting glass tube in another flask. This is how two miscible liquids, for example acetone and water, such mixture can be separated into its constituents, can be separated into two substances with the help of distillation. Now, for distillation, we need a mixture of such two liquids which have their boiling points at least on a distance more than 25 K. Then what about the liquids, or what about the substances which have their boiling points in a shorter distance than 25 K? We use fragmented distillation for that, or we can call it as a fractional distillation. Now, with the help of distillation, where the boiling points, apart from boiling points of two liquids, are actually apart more than 25 K, with the help of distillation we can separate such two liquids. But let's take an example of air. The air which is there in the atmosphere, how do we separate? It's a homogeneous mixture of different gases. We all know that. We know about the nitrogen, oxygen, carbon dioxide, argon, many other gases in a very small fraction, but they are there and they make a homogeneous mixture. How to separate these different gases from the air? There also we use distillation process, but we need to utilize fractional distillation. What is the difference between distillation and fractional distillation? Actually, fractional distillation process instrument just only have an extra fractional part, a fractional condenser into it. That fractional condenser has got different glass globes or tubes, so that the area, surface area for condensation of vaporized substance is more, so that even in the lesser gap of the temperature we can get the substance condensed and liquefied once again and separated from the mixture before it reaches the next boiling point of another substance.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment, and make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group, and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.